Vortex meters offer many advantages for flow measurement, including easy installation without impulse lines, no moving parts to maintain or repair, less leak potential, and a wide flow turndown range. Vortex flow meters are comprised of a meter body, a sensor, and a transmitter, which together measure the volumetric flow rate. Within a vortex flow meter, an obstruction in the flow path, often referred to as a shutter bar, causes process fluid to separate and form areas of alternating differential pressure, known as vortices, around the backside of the shutter bar. These vortices then cause a small sensing element either behind or within the shutter bar to oscillate back and forth at a specific frequency. The velocity of the working fluid is directly proportional to the frequency of the vortices generated by the shutter bar's unique geometry. Using the known cross-sectional area of the pipe, volumetric flow can be calculated. This flow principle is referred to as the von Karman effect, a proportionality constant which relates the frequency of the alternating vortices to flow rate. The calibration constant is formed in a flow lab by measuring the amount of pulses that are generated per 1 unit of volumetric flow. This calibration constant is accurate over a wide operating range of Reynolds numbers. Because vortices must form in order for the vortex technology to pick up a signal, an adequate ratio of inertial forces to viscous forces must exist. If not, the meter will read no flow when the fluid is flowing. Once a mechanical signal has been formed by the vortices passing by the shutter bar, a sensing element takes the mechanical motion generated by the flexure and converts it into an electrical signal. This electrical signal is then passed from the sensing element through a circuit up to the electronics board stack, where it is then processed and turned into a quantifiable velocity reading. This signal is then outputted to the vortex's local display and out to the control system. Vortex flow meters are well suited for a wide range of applications and can accommodate liquids, gases, and steam while being able to withstand high process pressures and temperatures. Vortex flow meters are also a two-wire device, making them efficient with respect to power consumption. Vortex meters are available in a variety of meter body configurations and multivariable capabilities, allowing for compensated mass flow readings. By measuring additional variables such as pressure or temperature, along with the volumetric flow reading, fluctuations in density can be accounted for to provide an accurate mass flow reading. Compensated vortex flow meters can prove to be especially useful in saturated and superheated steam applications, along with liquid applications in which the fluid is nearing its saturation point. Low flow cutoffs and minimal measurable flows can pose an issue to vortex technology. One solution to this limitation is utilizing a vortex flow meter known as a reducer. This configuration decreases the cross-sectional area of the meter body by one line size, yielding a higher velocity through the pipe. With a higher velocity passing by the shutter bar, lower flow rates can be accurately measured. Reducer vortex flow meters use the same face-to-face dimensions as standard flanged vortex meters, which decreases cost by eliminating the need for field-installed piping reductions. For chemical plants and refineries, safety instrumented systems, or SIS applications, are critical to keep a plant running smoothly and safely. Dual and quad vortex flow meter configurations exist to accommodate these type of applications by providing redundant, independent sensors and electronics. This provides redundancy for uncommon modes of failures and helps to protect against spurious trips that these plants may experience. Emerson's Rosemount vortex flow meters offer unmatched reliability using an all-welded, all-cast design with online removable sensors for enhanced safety and maximum process availability. Emerson also offers the widest selection of materials to provide a tailored solution for any process or utility challenge.